Okay, so we're given this system of equations by elimination. 3x plus 3y equals 6. 3x minus y equals negative 6. If we add these, then 3x plus 3x equals 6x, and 3x plus negative y is 2y. That doesn't eliminate anything. The previous example we added. This example we're actually going to subtract. So we're going to subtract our two equations. And make sure you do this term by term or piece by piece, because otherwise you can get a little bit lost. 3x minus 3x. Well, 3x minus 3x is 0, so those cancel. 3y minus negative y. Okay, so a lot of times we're tempted to say, okay, 3y minus y. Well, that's 2y, but what we're actually doing is subtracting a negative. If we subtract a negative, it becomes a plus. So 3y minus a negative y is going to be a plus y, so that's 4y. And 6 minus a negative 6, so minus a negative again, right? Think of you're taking away a negative, and so it's the same thing as adding. So 6 minus a negative 6, 6 plus 6, that would be 12. Divide both sides by 4. And y equals 3. Okay, so now we can plug that back in. Let's just plug it into the second equation. It doesn't matter. You can pick either. 3x, we don't know what x is yet, minus y, we know is 3. So 3 equals negative 6. I'm going to add 3 to both sides. And negative 3 and a positive 3 are going to cancel. And that gives me 3x equals negative 6 plus 3 is negative 3. Divide both sides by 3. And we get x. That's going to 3 divided by 3 is a 1. And negative 3 divided by 3 is a negative 1. So x equals negative 1. Our ordered pair would be negative 1, 3. Okay. And then at least for all of these, you're either going to add or subtract. You're going to find a variable. You're going to find something that looks the same. So 3x and 3x, those are the same. So if we subtract, we get rid of them. If it was a negative like the previous example, then we would add them and they would cancel each other out. Okay, you can add or subtract. You're still adding or subtracting the same amount of weight from each side of the scale. And so either is valid.